Okay, so what we're looking at here is an example from 2021 of a parametric equation problem. A and B on this one are very, very straightforward. Letter C, it's a little bit more involved, so we'll take a look at that one in just a second, but let's go ahead and jump right in. You'll notice that we've got, for time is greater than 0, particle moves in the xy plane with the position x of t, y of t, and then it gives us the velocity vector. Then it also gives us an initial position for the particle that we're talking about. So again, fairly straightforward so far. Letter A says find the speed of the particle at time equals 1.2. So let's go ahead and do that first. The speed of the particle is just dx dt squared plus dy dt squared, and then we take the square root of that when, and this is the part that's important, we do need to plug in time equals 1.2. So you'll notice there's no integral here. It just wants to know, do you know, the correct formula for speed? And that is 1.271. There's the speed of my particle. To find the acceleration vector, what we have to do is we have to take the derivative of dx dt. So I basically need my acceleration vector. So I'll take the derivative of dx dt and put it there once I plug in 1.2. Then do the same thing for dy dt. And when you do that, you get 6.247 for the x component of the acceleration vector, and 0.405 for the y component of the acceleration vector. There are your answers for letter A. Letter B wants to know the total distance traveled of the particle from time equals 0 to 1.2. Now, because this is a parametric equation and not just a normal function, we do use a slightly different formula, but it's still pretty easy. We just take the integral of our speed function from 0 to 1.2, and when you do that, you get 1.0009 or something like that, so it rounds to 1.01. There's your answer for letter B. Again, A and B pretty easy. Letter C says find the coordinates of the point at which the particle is furthest to the left. So in the end, and then there's more to this problem. In the end, I'm going to have to find an x value, and I'm going to have to find a y value. In order to find those things, I have to take my initial x value plus the integral from when they happen to when we want to find it, which we don't know yet. We take the integral of dx dt. And then for the y value, we do exactly the same thing. I do the integral from 0 to dy dt, and then I have a dt on the end of that as well. So really the thing that we need to worry about here is, what is the time that the particle is farthest to the left? Well, in order to realize what's going on here, we have to remember that dx dt tells us how the particle is moving in the left and right direction. So what I'm looking for, I'm going to graph this function, and I'm going to find out to see where it's moving to the left, which means when my velocity function is negative. It just so happens that when time is greater than 0, what happens on that graph is it kind of does this. It's below the x-axis until that point right there, and then it never, ever crosses again. So at time equals 1 is where the particle is farthest to the left, which means that's when I want to find those right there. And I plug each of those into the calculator, and I get negative 2.604, and I get 5.410. That's my x value and my y value. Then I have to explain why there is no point at which the particle is farthest to the right. The easiest way to understand that is because this function, the dx dt, is always positive after time equals 1, that means that the particle is continuing to move to the right forever after time equals 1. So it's always moving to the right, which means there is no furthest point to the right. And there's a lot of different ways you could write that, as long as you indicate that you understand that the derivative dx dt never crosses the x-axis again, and it's always positive after that point. You will get all the points on that one. So again, like I said, pretty straightforward on how you do this particular problem. It's a good particle motion problem, goes over a lot of things, and it has a little bit of a twist at the end that makes it a little bit more difficult. Hopefully you understood all of that. If you have any questions, please let me know.